Keith Fang. And I also see Lydia Melnick, who is the speaker for the second paper. And could you please open the list of the people who are present here?
Yes.
Thank you very much.
Yes.
And so far we do not have the speaker for the third paper, but we'll be hoping that the person will arrive at proper time. So it is my pleasure to introduce the first talk given by Nguyen Thi Gan from the Industrial University of the Ho Chi Minh City in Vietnam. He will be talking about the Aic algorithm for a decision to choose the supermarket. It's a very nice application for artificial intelligence, I will say. So the floor is yours. Please go ahead. The time budget is roughly 20 minutes, with 10 minutes for questions or whatever. Now, overall slot is 30 minutes for the presentation plus questions. So please go ahead, share your screen with us and start your presentation. The first paper, Nguyen Thi Fang.
Yeah, can you see my slide?
Not yet. We're waiting for those. Yeah, appearing.
No.
Yes.
Can you see it?
Yeah,
Thank
it's
you.
fine now. Please start your talk.
Yeah. Good afternoon, Professor Vadim. Good afternoon, ladies and gentlemen. My name is Khoi. I'm a lecturer from Industrial University of Ho Chi Minh City. Today, I would like to thank the ICT-Research 2021 for giving me an opportunity to talk about the topic Aic algorithm for making decision on the supermarket choice evident from Vietnam. My group has two members, Nguyễn Thị Ngân and me. We are coming Industrial University of Ho Chi Minh City. I will represent our topic to talk about the findings, the introduction, literature review, methodology, result, and conclusion. Now, I would like to turn to the introduction session. As you can know, the supermarket business always welcome in a Vietnam retail market. Because the retail market is a potent market bringing high profit for participating business. There are many supermarkets in Vietnam. Retail sale of products total 3 billion Vietnam, account for 76% of overall retail sales and up to 12.8% from the same year last year. In the papers explore the factor influencing making decision on the supermarket choice evident from Vietnam. The data collected to a survey of 201 clients living in Ho Chi Minh City, Vietnam. We use the Aic algorithm for the making decision on the supermarket choice. Now we turn to the literature review. Because the limit of the time, I introduce the brief of literature review. The first part is the relevant previous studies. And the second, we talk about the factor influence the decision to choose the supermarket as follow: the perception of price and products, the location, attitude of the employees, and reference. That's all. We give 4 factors affecting the decision to choose the supermarket at the shopping rest of Ho Chi Minh City. Consumer includes price and product perception, location, employees, attitude, and relevance. Now we turn to the methodology. The methodology is talk about the sample size. The sample size, according to Boland, the minimum sample of size is 5 sample for each parameter to estimate. The sample size can be defined as 5 plus 1, 5 observation per 1 variables. In this study, there are 21 variables. Therefore, the medium sample size can be calculated 105. Although the minimum sample size requires only 105 survey, we submit go 221 survey questionnaire direct in the internet with tool the supporting Google Forms for consumer to ensure sample diversity and representatives. This is the factor and item. There are 21 observation for the 5 factors, 4 factor dependent and 1 independent. Now we turn to the result. The result are 2 parts. The first is the AIC algorithm, and the second model evaluation. The AIC algorithm are programs use the AIC to select the best model. In the theoretical environment, AIC has been used to select the model. The AIC technique can also handle many. AIC can be regression model to estimate 1 or more dependent. Each step for the ask what for the decision step for independent variable has AIC 355.12. This is the we use t value and p value. The p value for variable less than 0.05, so they are correlated with the decision to choose supermarket in the table was influence the perception of price and product, location, attitude, and employee and reference. All of the factor as accepted. The VIF for independent variables is less than 10. As a result, the independent are not collinearity because the p value 0.04 is less than 0.05. The Dubin question show that the table has autocorrelation. The perception and product location impact the decision to the supermarket is 51.29%. The regression equation below has significant about the talk about the conclusion. The result of the analysis of the influence from high to low are the location, perception of price and product, reference, attitude of employees. The business can or company can influence the above the factor to promote their business and create customer loyalty. I would like to be happy for giving me comments to my email. Thank you so much. Thank you for Professor Vadim. Thank you, everyone.
Thank you. Thank you. Could you please open the chat?
Okay.
While the chat is opened, I would like to remind that the virtual room chat is used for posing the questions. I do the question by raising hand. You may raise hand, by the way, using the functionality here in Google Meet. But as Vitaly Kogas has raised up his hand, I would suggest that he asks his question. Vitaly, your floor.
Thank you. So I have a question. During your presentation, you demonstrated archaic criteria, which is used for different model and demonstrate the quality of different model, and the smallest criteria, the better quality. Would you please to explain what kind of models did you consider, and what model demonstrates better results?
Thank you for the question. The model is the supermarket is the main factor, and four factor influence the supermarket is the perception of price, product, and location, attitude of the employees, and the last reference. This is the result of the model here. The decision to choice supermarket equal 0.49925 plus 0.126 perception, and 0.5 location, and attitude, and reference here. The most important to decision is location. The location. Yeah, thank you.
Okay, do you have any more questions, please? Thank you. While people are thinking about their questions, I would prefer that you go back to the slide with your model evaluation again. Could you please go back to a slide with model evaluation? It's number 8. Yes. For model evaluation, the p-value is equal to 0. Is it explainable, or what is the reason for having 0 for p-value here?
Okay. Is it a model evaluation? The p-value to test the first is the autocorrelation between the independent for independent. The p-value lower than 0.0405. So there are not autocorrelation in the models. And the second, the p-value 0.0 the F test by Fisher is important for factor impacting the decision about 51.29%. Yeah.
Okay. Okay, thank you. Does anyone have a question?
Thank you so much.
There's one more question from the text. Did you check multicollinearity between explanatory variables? You may open the chat box and read these questions yourself. The question was, did you check multicollinearity between explanatory variables?
autocorrelation, p-value is the 0.04, lower 0.05. So there is no autocorrelation in my model.
Looks like they did not detect any multicollinearity. One more question: what are the factors that are statistically significant, and which ones are insignificant for explanatory variables? Which factors are significant and which are not significant? Could you please point out?
The most significant in this model is location from the house of customer to the supermarket. The far from the house of customer to supermarket is the most important. And
is it about the distance or location? Are you speaking about the distance from one point to the other point? Or it's about location? Location is characterized by several places of interest in the location, like a supermarket, a drugstore, and something else, a cinema. This is a location. And if it's all about the distance, then it's just in kilometers. So
kilometers,
So it's the distance in your case, right?
The distance in about the research about lower 5 kilometer. 5 kilometer.
Okay. Excellent. Does anyone has more questions, please? If not, so thank you very much.
Yeah, thank you.
For your presentation.
Thank you so much.
And for the answers. So we switch to the next paper, and it's my pleasure to introduce the next speaker, who is Lida Melnik from Ternopil Ivan National University in Ukraine, and will be presenting the paper titled "The Unification of Approaches to Measuring Digital Maturity of Infrastructures, International and Domestic Approaches." So thank you very much for sharing your presentation. The floor is yours.
Hello, all participants of the conference. Well, let me introduce to your attention the results actually of our research. As you see, the unification of approaches to measuring digital maturity of business structure, the international or domestic approach, and well, as you see, the group of authors is quite bright. We have 5 authors. All of us are specialists in different sphere, but nevertheless it gave us the possibility to measure, to gather together all of us and to present to your attention this research. Well, I will show shortly the plan of our research. We have an introduction. And then we have a problem analysis, and which actually here we are going to talk about the digital scoreboard of the European community, global statistical indices of the 11 countries' digital development, digitalization of the national statistical systems as an important step towards the development of the digital economy. And next we have, we would like to talk about the importance of digitalization of micro and small business. Then we would like to show our practical results and as a common conclusion. Well, so let's start. Actually, the current state of implementation of digital technologies in domestic business differs significantly from the world. Due to the low general level of digitalization of the domestic economic space, the use of international methodologies for measuring the digitalization of business actually is not acceptable. The main indicators for assessing the development of the digital economy in the EU are a number of global indices. Based on certain statistical methodologies and observation, they reflect the level of development of the digital economy in different countries. And among such tools, we can single out the most global. Actually, as you see on this slide, we divided them in general into 4 groups. Our country is not included, as you see, in a number of ratings, however, declares a plan for implementation in the relevant rating systems. For instance, the index DESI. It declares implement in these systems in the near future and predicts the leading position. I would like to tell you a little about each group. For instance, the first group indices include Global Competitiveness Index and Global Innovation Index. And the first one, Global Competitiveness Index, consists of 113 variables that detail the competitiveness of countries around the world at different levels of economic development. And among 137 countries in 2018, Ukraine ranked 81st place. One more global index, actually, which is included in this group, as you see, that is Global Innovation Index, and it consists of 80 indicators, and 126 countries are evaluated in reference to this index. This index is based on 2 sub-indices, the Innovation Contribution Index and the Innovation Issue Index. And in 2018, Ukraine took 43rd place, which is 7 steps higher than the previous year, 2017. Ukraine demonstrates the highest indicators of innovation in education and science. It was 43rd place in the ranking, and business, it was 46th place. Also it should be noted that institutions and infrastructure remain the least innovative. The place was 107th and 89th place respectively. The second group indices reflect the state of infrastructure for the effective development of the economy, included its digital component. As you see, it includes 2 indexes, Network Readiness Index and Broadband Penetration Index. Network Readiness Index is used to assess the driving factors and the impact of network readiness and ICT capabilities in a particular country. And the index consists of 4 sub-indices that assess the environment for ICT development, society's readiness to use ICT, the actual use ICT by the state, business, and the population, as well as the consequences of ICT in the economy and society. Regarding Ukraine's ranking, the country failed to demonstrate high position in the Network Readiness Index. The lag behind the components of the use of technology by the public, business, and government, it was 88th place, is the main reason for Ukrainian slow results in the world rankings. The next index of this group is Broadband Penetration Index. And in addition to high-speed broadband access provides a continuous connection to the internet and so-called two-way connection. It is the ability to both receive and transmit information at high speed. Ukraine's position is at the bottom of the pile and needs actually to be improved. Group third indices, which is reflect the level of digital development of the countries, comprised of 6 indexes, as you see. But Ukraine was ranked just according to 3 of them. That was World Digital Competitiveness, Ict Development Index, and Digital Evaluation Index. The first one, VDC, reflects the effectiveness of the efforts that have been invested in the development of the digital economy, as well as reflects the effects of the contribution of digital technologies on the efficiency of the country, and provides an opportunity to assess and manage digital transformation. And Ukrainian's position in this ranking is 58 out of 63 countries, which were surveyed in this study. The Ict Development Index is designed to monitor the development of IT in countries and their position in the global IT market, and measuring progress in ICT development in both developed and developing countries, identifying the digital divide, identifying the potential of ICT development and the level to which countries can use it to increase their own growth and development. And the another one, Digital Evolution Index, which ranks countries based on their progress in digital development. Here are like 2 sub indexes. First, level of quality and readiness of digital and physical access infrastructure. And the second one, requirements for digital technologies. And DEI, this index, includes 90 countries evaluated across over 100 different indicators. And in 2019, Ukraine took 62nd place. And the fourth group of indices include, again, 2 indexes, Dell Technology, DT Index, and IDSME Index, Evaluation of Smart Digitalization. And DT Index is a global ranking that indicates the status of digital business transformation. And the another one, IDSME Index Evaluation of Smart Digitalization, covers companies of different size and different areas in just 3 countries, Russia, Serbia, and Slovakia. Well, as the Ukraine, as you see, is not reflected in many global rankings for the development of digital economy, which we just recently saw, this, we realize that there is a great problem with understanding the general trend of change in the domestic digital infrastructure and its position in the global digital context. Declared in the government the concept for the development of the digital economy and society of Ukraine for 2018-2020. Measures to stimulate the economy and attract investment, overcome digital inequality, deepen cooperation with the EU in the digital sphere, and build the country's innovation infrastructure and digital transformation. Not fully implemented, but the government of our country declares the following plans for the position of our country in the global rankings. And actually we can see on the table the plans of our country to be ranked in those global ranking systems. Well, also it should be noted that in order to be able to integrate Ukraine into the relevant global indices, it is necessary first unify the groups of statistical indicators, taking into account the differences in the national specifics of digitalization processes and their measurement. Official statistics do not calculate the size of the digital economy in Ukraine, Which make it impossible to track progress in the process of its digitalization. And today, only the digital economy is measured in narrow sense. High-tech products, digitalized services, and so on are not accounted for. Well, now you see the comparison of national statistical system of the technological capabilities of information collection and processing on this slide. Right now, we compare Ukraine, Estonia, Singapore, and the European countries. And here, as we see, Ukraine demonstrates a low position, for instance, for unavailability of microdata, inability to work with data, an ability to predict indicators and closed access for the API. And this situation is caused in most due to the using some formats for uploading ready-made data. And as you see, we use mostly such format as doc, PDF, Excels. But in other countries, use more more different formats, and this gives them the more possibilities to work out with this data. We are convinced that further research of the state of digitalization indicators in Ukraine should be conducted in three main areas. For instance, the first one, the development of recommendation for the adaptation of statistical indicators to EU standards. The second area, that is the development of methods for conducting specialized careers in the field of digitalization statistics. And the another one, justification of the use of available indicators that do not fully meet EU standards, but reflect important processes related to digitalization in the national economy. In fact, the basis of economic and social well-being, both in Ukraine and in the countries of the European Union, are small and medium enterprises, which comprise more than 99.5% of the total number of enterprises in the EU, where more than 66% workers are suppliers and bring out 60% of value added to the total budget. A small and medium business in Ukraine occupies a significant part of the economy as well. It generates 47.2% of total value added, and the level of employment is more than 60%. Therefore, special attention, as we find it important, should be paid to effective digital support and digital promotion for those small business, both at the European and national levels. And based on the above provided analysis, it is necessary to develop own methodology for determining the index of digital business transformation, which would take into account the realities and specifics of the domestic market and reflect an in-depth understanding of the process of digitalization of the domestic business environment. And in view of this, there has been designed a new approach to the definition of the index of digital transformation of business structure, which has the characteristics of the complex system HIT, which is namely the separation of some levels, three levels of groups of indicators, which in turn contain a system of sub-indicators with appropriate weights. Actually, the presentation of this HIT methodology of calculation of this index was presented in our the previous Ict conference, the last year. Well, as a conclusion, we would like to notice that the annual assessment of the Ict Business Digital Transformation Index would serve as a tool for monitoring and assessing the effectiveness of doing business in the era of the digital economy, helping to identify barriers to the development of small and medium-sized business, forming a list of priority economic, legal, and regulatory measures, that is reforms, to improve the implementation of digital technologies in the activities of domestic business structure, and would contribute to the integration of domestic business into the digital economy of the world. Well, thanks for your attention.
Thank you very much. Do I have questions from the audience, please? So far, no questions in the chat box, so I'd like to ask my... Vitaly, do you have a question?
Yes, thank you. I sent my question in chat box, but I can tell about my question.
Yeah, go ahead.
Thank you. So thank you for your presentation and for your opinion about digital index. My first question, what is your research question in this presentation? And my second question, what difference between index of digital transformation of business structure in Ukraine proposed by yours and European digital index?
Okay,
Switch on your mic.
Sorry. Well, thank you for your question. According to the difference between those indexes, and actually what was like the purpose to develop, right, our new approaches, that is, there is a well-known for European countries indexes which is called DESI, and DESI, well, all of European countries are ranked according to this index. DESI include it's based on five sub-indexes: the connection, the human resources, use of internet services, integration of digital technologies, and digital public services. And according to the Ukraine, for us, it's for now it's impossible to be ranked according to this popular index for European countries, and that is why we decided to propose these new approaches, at least to show what is the actual level of the digitalization of business structure. We imagine that it's like just a first step, because now we are trying to analyze just business structure, and even not all of business structure, but small and medium-sized infrastructure. We imagine that obviously that we have like to expand more business structures, but like that's actually our plans for the future researches. According to the European countries, they studied, for instance, this index mostly based on big companies and medium. They didn't took into account the small business. Now they imagine that really small business, it makes great impact for the national economy. So now they are trying like to develop this DESI, this methodology, which will help or give the possibility to analyze the small business. For now, like that's our the presentation, like how to calculate on the national level. So that is why like the difference, actually what's like the impulse, right, to develop this methodology.
Thank you.
Thank you.
Okay. More questions from the audience, please? No? Then I have a question. Could you please return back to slide number 10?
Number 10, just
Yeah, just the previous one.
Just give me a second, please.
Yes. Yeah, this hit index. So I followed the structure of your presentation. You first presented the well-known European indices.
Yes.
Then you have said that those European indices do not fly for Ukraine, and therefore you have invented this hit index. Then you said that hit index has been presented last year in the Ict conference. So my question now, what is the contribution of this paper?
Yes, we wanted to show you that actually what was the great reason to present this and how it fits into the global methodology of calculation the indexes of digital transformation. But the main point here that is we are trying to show how it works for a business structure. Now we have some practical results of using this methodology. We calculated, let's say, this index on a business structure of more than 34, right? 34 business structure, and it shows us some results. And like based on these results, now we are working at the development of some recommendation that is like a roadmap for those business structure who were questioned. So like here we developed again this methodology or this approach.
I'm a little bit lost here. Please clarify. What is the results you have presented this year in this conference, in the paper you have been preparing? And what is your future work?
Yes, the practical results of this, that we could like divide those business structure who has a low level actually of index of digital transformation, who has a little bit better position, and we like segmented the results of the number of participants on a cluster. And this gave us like to work for development some recommendation for them. And our next step in our research, that will be the developing some like roadmap and for those business structures. And we have like started actually to develop a platform which will help to do this more like quickly, and it would be like with the open access to another business structure. So like that's our plans for the future research.
Okay. It's a little bit of a pity that you did not present these practical results, which are value in your presentation. Mm-hmm. Instead, that you spent your time for presenting the things we already know. So thank you very much.
Thank you.
Let's last call for questions from the audience, please. Do you have any more? Nothing in the chat box so far. So thank you very much.
Thank you.
Thank you very much. And it's my pleasure to present our third talk given by Dmytro Terlecki. The title is Difference of Quasi-Homogeneous Classes of Objects. Dmytro, could you please share your presentation with us?
Hello. Could I have the access to the sharing? Yes. Okay.
Yeah. Stop sharing, because the previous presentation has been shared.
Mm-hmm. Okay.
Yes.
Okay.
That's it.
So
just a second, we do not see your presentation as yet. Please pin it to the screen if you have shared a presentation.
Is it visible?
Not yet. Yes. It is visible now. Thank you. Could you please switch it to the presentation mode?
Yes, wait a moment. Oh, yes.
Just a second, it's not switched to the presentation mode.
So, could I? No, it should work.
It should, but it doesn't. Yeah. Much better. Thank you very much. Please go ahead. The floor is yours.
Okay, thank you. My name is Dmytro Terletsky. I'm working on Viktor Glushko Institute of Cybernetics of National Academy of Science of Ukraine. And I'm working in Department of Methods and Technological Tools for Construction of Intelligent Software Systems. And as you probably guess from the title of the department, our research area is the intelligent software systems, especially knowledge-based systems. So, and today my talk will be about some results in our research for construction of intelligent knowledge-based systems, and we will discuss the case related to the fuzzy knowledge, because as you know, there are different kinds of knowledge and different kinds of models for representations and so on. And today we'll discuss the difference of fuzzy homogeneous classes of objects. Let me show you a short agenda of my presentation, and let us begin. So, as I told you, we are working with construction of knowledge-based systems, and here you can see the general scheme or architecture of the knowledge-based system. And as we can see, the usual elements of the system is the knowledge base, user interface, inference engine, representation engine, expert interface, and so on. And of course, in some particular systems, some particular systems can have another engines or modules which have some additional functionality. However, here I hope I presented all most common of them, and this research which I want to present to you, we are focused on the integration part of the knowledge-based system. What does it mean? When the system extracts the knowledge from some domain knowledge sources, it could be web pages, it could be knowledge bases, databases, some particular files with information, and so on. Or another situation when the expert using the corresponding interface using the acquisition engine put some knowledge into the system, then this knowledge should be transformed according to the representation model which the system uses. So, and after that, that knowledge should be integrated in the knowledge base, because in this knowledge base we have some other knowledge which we obtained previously. So, and this integration procedure is sometimes is quite hard, but it is very important, because if we perform it without any errors, then inference engine, for example, will work well, and we will not have some contradictions in the knowledge base, some artifacts which will broke the inference engine, which can grow the complexity of reasoning and so on. And here is the short definition of Kenneth Murray, what is the knowledge integration. And as I told, this is the process when we try to integrate some knowledge items or pieces of knowledge into the existing knowledge base. And Murray and his colleague Bruce Porter proposed the computational model for this process. And here's the three main prominent activities in this model. The recognition stage, it is the stage when the system should recognize the relevance between new knowledge and those which one was were previously integrated into the system. And then on the elaboration stage, the system should find or estimate the possible effectiveness of new knowledge onto the let's say previous knowledge. So, and after that, the third step is the adaptation. It means the actual integration of the new knowledge into the knowledge base. And with this in this stage, we actually try to avoid some negative results, I mean contradictions or so on. And this is the general idea of the knowledge integration. Of course, it could be modified or specified in every of these stages more precisely. However, it's enough to understand what is the knowledge integration. So here is the short list of the articles and conference papers where you can find more details about this model, because this model also was implemented on the KI tool, and this is huge knowledge based system, knowledge based system which helps the engineer to collect the knowledge about botany garden. I guess it was a big project in the USA, and if you are interested, you can you can find the information about these results here. So let us talk about the knowledge structures which the knowledge-based system could use during the knowledge integration. Of course, everything depends on the particular knowledge representation model. And there are a lot of approaches, and currently we are working on object-oriented approach. So as you probably know, the main knowledge structures within this approach is the are objects, classes of these objects, and actually relations among them. So when we are talking about fuzzy case, when our concepts or let's say knowledge in more general way are fuzzy or vague, imprecise, we need to use some more flexible mechanisms for representation. And here is the list of main representation structures in the case of fuzzy knowledge within the object-oriented approach. So here you can see three cases: fuzzy classes of fuzzy objects, and fuzzy classes of crisp objects, and fuzzy classes of fuzzy objects. And this classification was introduced by Ma. It is a researcher from China, and his research related to the fuzzy object-oriented databases. And Also, we have the fuzzy relation among these fuzzy objects and fuzzy classes. Uh, uh, then so we will discuss just this case sorry, this case, fuzzy classes of fuzzy objects today, and some our results which we achieved. So as I told, the knowledge integration process is very hard, but also important part of the modern knowledge-based systems. And during the integration process, some related problems can appear, and here's the some list of this of such problems. When we try to integrate, or I say we tried, I mean the system, knowledge-based system tries automatically integrate this pieces or of knowledge or knowledge items. Uh, it should check the knowledge relevance, equivalence, inclusion, similarity, or difference, because it is very important during the integration of new knowledge items, and it is allows us to avoid the representation redundancy. It is also allows us to avoid some future logical conflicts for reasonable inference engine. So therefore, we need to analyze the knowledge which we extracted or acquired previously, and decide what is the difference between them and those pieces of knowledge which were integrated previously in the knowledge into the knowledge base. What is the common, what is the difference? And in our research, which I want to present to you today, we worked with knowledge difference, in more particular with the difference of fuzzy homogeneous classes of objects when we consider the object-oriented approach with fuzzy knowledge. So we are working with the such knowledge-based knowledge representation model as fuzzy object-oriented dynamic networks. Later, I will show some reference where you can find more information about this model. It is object-oriented approach, and here you can see the definition, what is the fuzzy homogeneous class of objects. And I need to explain a little bit more about what we mean call when we say homogeneous. As you know from basic knowledge from object-oriented programming on all object-oriented approach in general, that all classes define some set or collection of objects, and all objects of the same class have the same structure defined by the attributes, and the same behavior defined by this collection of methods. And in this sense, such classes are homogeneous because all objects of the class have the same structure and same behavior. And when we say fuzzy homogeneous class, we need to count the situation when the particular attribute or property, here we use P to denote the property, and use F denote the methods. And both or methods and attributes or properties can be fuzzy ones. And also the class could be fuzzy itself, and it means that each property or method can be can belongs to the class fuzzy class with some measure, and it is the main feature of fuzzy class. So as you can see, such class defines some fuzzy type, which consists of particular properties, fuzzy properties, or fuzzy methods. Of course, some of them could be the crisp ones. It means the mu will be equal to 1, and some of them will be fuzzy. And also, what is important, here we use this method, this formula for computing the fuzziness of the class itself. And this formula is different from other approach, so which we found on the articles, papers, and so on. Okay. Here you can see the example of the fuzzy homogeneous class of objects in terms of fuzzy object-oriented dynamic networks. And this class defines the fuzzy concept of a city car. And you can see here 8 properties and 1 method. And here you can see also the measure of fuzziness for each property or method. And those properties which have the such measure equal to 1, they are crisp ones, and some of them, some other properties has the measure of fuzziness differ from 1, so they are fuzzy ones. And you can see that we have the property which defines engine type, engine volume, engine power, maximum speed of the car, sizes of the car. Here we see the compactness property, capacity, noise. I need to comment a little bit more about those properties. A few important things. First of all, within the fuzzy object-oriented dynamic network, there are 2 kinds of properties: qualitative and quantitative. Quantitative properties, you can see here, it is P1, P2, P3. And qualitative property is P6, because it's definite as the verification function, which verifies some property and maps the result in the interval of the real numbers from 0 to 1. And it's something like a predicate in the logic. However, it is fuzzy one. And also we have the fuzzy, here we have the crisp method, but in other cases it could be fuzzy. And what is the fuzzy method? In our case, it is the fuzzification methods or defuzzification methods. If you are familiar with fuzzy controllers, you probably heard about such kind of methods. So how we define the difference between such structures, I mean fuzzy homogeneous classes. Here's the short definition. When we have 2 classes, fuzzy classes of objects, which defines some fuzzy types, T1 and T2, the result of the difference will be another one fuzzy type, 1 set minus 2, which for which should be satisfied the following condition. It is very close to the idea of set differences. The difference when we have set A and let's say set B, and we want to compute set theoretical difference between 2 sets. However, this situation is much more complex, because we have more complex elements inside these sets. If we say that a class of object or type is represented as the set of attributes and methods. So what actually we have in the results. We proposed the algorithm, we developed the algorithm based on the previous definition, and this algorithm verifies the equivalence of fuzzy qualitative and quantitative properties as well as fuzzy methods. And in this way, we we implement the idea of difference between two classes. Because when we try to compute difference between two sets, for example, two sets of numbers, it is enough to know is it two elements from different set are equal or not, and then we can compute the difference. So in this way, the equivalence verification or equivalence check is more complex. I didn't put much more details about this because it is a big piece of information, but you can find these details in our paper, and the links for more details for each of this procedure. It is they also were implemented in corresponding algorithms and published in the previous research papers, and I will show some links where you can find them later. So, and after result, in the result, after one algorithm finished the verification of these equivalences, it can construct fuzzy homogeneous class of object. Why I say can construct? Because, as you know, not for all cases between two arbitrary sets there is a difference. First set from second one, for example. And in those cases, when the first fuzzy class is, for example, a subclass of the second one, in those cases, the algorithm will return empty set, because in this case there is no difference between the first fuzzy homogeneous class of objects from the second one. Okay, let us conclude what we have done and some our results. So we consider some main knowledge analysis problems like difference, equivalence, inclusion, relevance, and we defined the universal exploiter fuzzy classes, and this is the difference exploiter. Exploiter notion of exploiter means that it is the some method, if you say in object-oriented way, or it is the operation, if you say in more algebraic way, which use the class as the parameter for construction new classes without changing those parameters. So, and it is the universal one because, as you know, set difference could be applied to arbitrary sets, and in the same way we use this idea and extend it for the fuzzy classes of objects. So therefore it is universal difference exploiter for fuzzy homogeneous classes of objects. Then we developed the algorithm which implement this difference procedure, and we can use it for construction new classes of objects, and it allows us to estimate the relevance between new knowledge items which we extracted or acquired, and those pieces of knowledge which were integrated into the knowledge base previously. And we can see what is new, what is not new, and using this information we can integrate those knowledge items without redundancy, representational redundancy. These results will help to construct more efficient this part of the knowledge-based systems, which we call integration engine or integration model. So, and in the end, here you can see some papers, conference papers of our previous research in this area. Here you can find the information about what is the fuzzy object-oriented dynamic networks, and the last papers represent another operations, or in other words, another exploiters, universal exploiters intersection union, and we try to construct this basic set of operations like union, difference, intersections, and symmetric difference as well, decomposition on the subsets, and this will be the operational suite for classes of objects, and in this way the knowledge-based system will be able to analyze the new knowledge items, generate new knowledge items, and so on. And this is the last slide of my presentation. Thank you for your patience and attention, and I'm ready to answer your questions.
Thank you very much for your nice presentation. Does anyone have a question? Okay, while people are thinking about their questions, I would ask you to go back to your slide, which displays the old-fashioned papers, last century papers, I would say, on knowledge integration. Yeah, that's one. As I have noticed, those papers are all dated the last century, 1989, 89, 90, 95, 96. Means 36 to 30 years from now. No, 40 to 36 years from now. Could you really rely on this background in your research work?
Yes, I agree about that. These papers are not new. However, the authors proposed the formal definition of knowledge integration. They described the formal model and implemented it in a huge knowledge-based system. We tried to find some new results, new concepts or notions or of knowledge integration, maybe new approach to this. However, we found only some practical implementations of particular systems, and therefore we used these results as the conceptual framework to understand what is the knowledge integration and how it could be implemented. And we proposed new ideas how this model could be extended, because those knowledge analysis tasks which I discussed during my presentation is some new steps and it more specific things inside this model. And it is very strange, however, after long searching, some specific journals, I mean knowledge-based system journal and expert systems and applications and so on and so on, we didn't find a new proposal in this area, I mean a knowledge integration model, or at least definition. So that's why we use this publication as the basis.
Which is not true. And, by the way, I guess I think you had to have a look at the papers published in the semantic web community, in the conceptual modeling community, in knowledge and information systems community, in data science community. There's an enormous number of papers dealing with knowledge and data integration in the last few years, including machine learning community and deep learning community. So go ahead and search. So it looks like you have missed vast body of knowledge between those ancient papers of last century and the front line of 2021. I'm quite sure that there are good papers for you to read and relevant papers for you to read, as far as I'm a knowledge and data engineer. So if you go further to the results which you present in this paper, I would like to have a comparison between the front end and back end. What I go into to claim as the contribution of this paper compared to your previous papers listed in the last 2 slides.
Okay. If we compare this paper, we present another exploiter and algorithm for its implementation, and we show how it could be used for during the knowledge integration process. And these exploiters, they have different applications in knowledge integration process, or even inference, because using these exploiters, we can construct new pieces of knowledge. We can find some unobvious features of particular knowledge items represented by in this case fuzzy classes of objects or fuzzy objects and so on. And it is the one of the ways to analyze those such knowledge structures. And this is just different approach and algorithms which can help us to see different perspectives. So and this is like one more step, one more part of our framework, because as I told in the end of my speech, we want to construct some framework with these operations definite over the fuzzy classes and integrate it into the knowledge-based system, which will be able dynamically, automatically calculate different differences, intersections, construct new knowledge items using the union operation. Also, union operation could be used for integration of new knowledge items, and difference exploiter allows us to compute the what is the different from new knowledge items in new knowledge items from the previous one which we already integrated into the knowledge base, and this is like additional function in the knowledge base system.
Okay, thank you very much for your explanation. As far as Ict is an engineering conference and practical conference, I'm asking about practical things. So could you please return to your conclusions? Number 5, you said, and please correct me if I cite you not directly, not verbatim. You said that the implementation of those beasts of methods for differences and other operations will lead you to more efficient knowledge integration routine. Do you know how? What's the relationship between the contribution of this paper and your claim number 5 in your conclusions?
Okay. When we want to integrate new knowledge items into the knowledge base, we need to analyze them and try to find some similarity. Maybe first of all, the relevance. Is the new knowledge items relevant to those which are already integrated? And if yes, we need to find the similarity or difference between these items. And our approach allows to compute the difference between new knowledge items and previously integrated ones, if such difference exists. If it's so, we can see what is the new part of the knowledge item for the knowledge base, or and what is the already known part. So, and we can avoid the representation redundancy by storing similar or almost the same knowledge items into the knowledge base, which could contradict each other during the inference process. And also in a few our previous papers we discussed another operations like union of fuzzy homogeneous classes, and we consider how new knowledge item could be integrated with the previous ones without representation redundancy. And here difference computation of difference between the knowledge items allows us to see to find those part which is unique, which is a new one in particular knowledge item, and using this information we can store in the knowledge base just this unique part, but not instead of storing all knowledge item with unique and known parts. So in this way, our results presented in this paper are related to this item 5 in our conclusions.
Okay, thank you very much. In this way, you have described right now, your results are not really new because they repeat all the things which have been implemented during the last 2 decades in ontology merging, ontology matching, and ontology instance migration operations. So please look at the papers that do that. Thank you very much. Any more questions from the audience? No, then thank you very much. This closes our session for today. Thank you all for coming. Thank you all for a fruitful discussion, and we are very pleased to have our three speakers today delivering the front-end knowledge on ICT advances in ICT research. Thank you very much, and goodbye. Looking forward to seeing you in the next Ict sessions. Goodbye.
Thank you. Bye.